Good evening. Now I'm going to explain about abstract. Basically, what we're going to see in this presentation, we use ventimeter, nozzle, and orifice plate as our measuring devices. These devices were used to determine and compare the coefficient of discharge, which is indicated as CD. Bernoulli equation was used to calculate volumetric flow rate of water of different flow meters. We studied that as the flow rate increases, the velocity will increase, hence obviously the pressure will decrease. Based on our experimental result, venturimeter gives more accurate measurement because its coefficient of discharge CD is higher compared to the orifice meter and nozzle. Basically, the discharge difference was closer to zero. That's why venturimeter is perfect.
Now I'm going to talk about the experiment. This experiment gives students to familiarize themselves with typical methods of flow of an incompressible fluid. This makes students easy to compare between different types of flow measurement devices by using a vector device, a device, and others. The data obtained can be compared. In short, the apparatus allows the experiment to be carried out for a comparison of flow measurement using battery or phase. So the objective of the experiment is to compare the discharge coefficient of different types of flow measurement and methods. So now for the theory. So when the Bernoulli equation can be applied to by referring point 1 and 2. The analysis for the equation for flow rate can be derived as below. The discharge coefficient defined as the ratio of the actual flow rate to over the theoretical flow rate QTH. Coefficient of discharge is equal to Q actual over Q theoretical. The equation can be written as log QACT equal to log n plus log delta. To find the n and n, we experimentally using a graph log QACT versus log delta. For the orifice plate diagram, the Bernoulli equation can be applied at point 1 and 3. From the analysis, the equation for flow rate can be derived as below. The discharge coefficient defined as the ratio of actual volume flow rate to theoretical volume flow rate. Coefficient of discharge is equal to Q actual over Q theoretical.
Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Moving to the next slide is methodology. Okay, what the apparatus that we use in this experiment, first of all, is number one, manometer tube. Number two, discharge valve. Number three, water inlet. Number four, gate valve. Number five, flow control valve. Number six, altimeter. Number seven, main switch box. Number eight, office plate or nozzle. Number nine, venturimeter. And the last one is the water outlet. Okay, the procedure, how to make this experiment become successful. So the procedure is the first one. The position of the office plate was properly set and the manometer tube was connected to the office plate. Number two, the gate valve and the flow control were closed and then turn main switch and the pump were turned on. At the same time, the gate valve and flow control was opened slowly until they reached their maximum opening point. Number four, the gate valve was opened slowly until the water level in H1 reaches a maximum of 390 and H2 pressure gauge is at the minimum level. Okay, after that, we must record all the reading. Number five, all the readings were recorded for the five different Q actual value. By adjusting or reducing the opening of the gate valve, the minimum Q actual value that we can get is about 200. Okay, the next one, the valve at the gate was closed and the pump was switched off. The manometer tube was removed from the office plate H1 and H2. Number 7, the nozzle was used to adjust the office plate and step 1 until 6 was repeated. Meanwhile, for the manometer tube were attached to H1 to H3 for the Venturi and similar measure from step 1 until step 6. Okay, number 8. All the manometer tube from the device after completion were removed and the flow control valve and the pump were closed, and also the main switch was turned off. And the last one, we must record all the data. Alright, the next one is the result. The data that we get is this: first nozzle, second office plate, and third one is Venturi meter. Okay, Q rotameter is L over H, volume water collected in meter cube, time in second, Q actual is meter cube per second, Q theory meter cube per second, H1 millimeter we must change to the meter, and H2 millimeter we must change also. So how to get the difference between H2 and H1? So H1 minus H2, we will get difference of H. And the last one is CD theory. Okay. So the next one is calculation. What the formula that we use in this experiment? Okay, the first one is Q actual equal to volume over time. Volume meter cube per time second. Number 2, Q theory. How to get Q theory? Q theory equal to A2 times square root 2G bracket H1 minus H2 over 1 minus A2 over A1 square. Okay, number 3, CD. How to get CD? So CD equal to Q actual over Q theory. Okay, the last part is discussion. There are 3 discussions that we need to discuss. The first one is the difference on water level H1 minus H2. Number 2, the difference in discharge coefficient value. Number 3, factor contributing to error. Okay, solution for the first one is this. Okay, Venturi of plate and nozzle. They are different between these apparatus. Okay, the first one is Venturi. Venturi consists of the segment that converge quickly, which increase the flow velocity and decrease the pressure by decreasing the cross-sectional area in the flow path and creating a pressure difference. The Venturi measure the flow rate of the fluid. Meanwhile, for the office plate, is the deviation between H1 and H2 is because of the lack of pressure. Office plate is a restriction with an opening smaller than the diameter of the pipe. If inserted into the pipe, it will causes the flow of velocity become increased due to the smaller opening area. Alright. And the last one is nozzle. So the nozzle is, there's a huge gap between the nozzle in H1 and H2. The velocity become increased as the fluid accelerates through the nozzle and the pressure become decreased. Okay, solution for the second one is this. In the flow meter, the ratio of a real discharge to the potential discharge is the discharge of coefficient, and due to loss of causes by wall shear strain. The losses in contraction and the losses during expansion, the discharge coefficient is less than unit. The fluctuation in the discharge coefficient are due to the different diameter of the contraction and expansion of the 3 flow meter, which is ventimeter, nozzle, and that's why is office plate. Okay, in this calculation, the head losses associated with the various meter and flow component have been made dimensionless by dividing the appropriate inlet kinetic heads. The advantage of the Venturi meter over the office meter and rotameter is evident through over a considerable range of inlet kinetic head. The loss associated with the rotameter is sufficiently small to consider that it will be more than compensated by the relative ease in evolution of the mass flow from this instrument. Okay, this is the Venturi. This is a calculation between Venturi of the spare and nozzle. See the average equal to, okay, so I make a calculation become this. So, therefore, CD is less than unity when there are losses occur. Therefore, office plate is less than nozzle and nozzle less than Venturi. Okay, the solution for the next one is what the factor contributing the error in this experiment. First of all is random error. So the random error might be always occur in every experiment. The first one is parallax error. Okay, parallax error occurs when the eye of the observer is not perpendicular to the scale or pointer. So the reading can be too high or low if the observer eye is not precisely perpendicular with the pointer and scale. Okay, number two is systematic error. So systematic error occur in apparatus. For example, air bubble shape in the apparatus. So the reading of the height of the manometer will also be affected. So the water will be not flow steadily, causing the height of the tip of change when the reading is taken. Okay, the last one, how to improve this experiment is, okay, how to improve? Number one, by inserting of a white paper behind the ruler. Okay, so another method is the eye of the observer must be perpendicular to the scale or the pointer. So parallax error can be minimized. Number two, ensure that the air bubble in the flexible tube is absolutely eliminated before the experiment. So to make sure the rate of flow of water will be steady at a constant velocity. So number three is by using the perfect device, we will get the perfect value. What is mean the perfect device? Perfect device meaning that the device less error. Alright, that's all for me. Thank you.
In conclusion, from this experiment, we managed to compare the discharge coefficient of different types of flow measurement methods. Our data proves that different types of flow measurements will provide different discharge coefficient. The flow rate was measured using a venturi, orifice, and a nozzle. Method of flow measurement is based on the differential pressure principle and it's related to the velocity of fluid flowing in a pipe. Bernoulli and continuity equations were used to calculate the theoretical flow rate of water. The accuracy is high and the reading of unity is close as the closer the value of CD to 1. Venturi is the most accurate with only 0.04 difference, followed by nozzle and orifice with 0.048 and 0.38 differences respectively. Due to the low pressure drop, values obtained for the venturimeter were close to the actual flow rate. Venturimeter has a high energy recovery. Some pressures may be lost in the converging part, but as the fluid flows back to the original dimension of the pipe, it attains back some percentage of pressure loss. Orifice plates creates large unrecoverable pressure due to the instability around the plate which leads to high energy consumption. Finally, energy loss in nozzles is higher than venturi but slower than orifice due to the small opening of nozzle that leads to decreasing in pressure and increasing in velocity. That's all from us. Thank you.